Hi there, and welcome to this tutorial on how to troubleshoot network issues like a pro using MTR or MyTraceRoute. This is a command or program which I use on Linux, but you can use it on Windows as well, but I prefer to use it on a Linux system. And you use this command to track down sporadic issues like packet loss and latency issues. And you can use it to locate the problematic hop in your path, in your network path, because a network often consists of multiple paths or multiple hops between the end hosts. And I have been using this tool for over 10 years, and this is my go-to tool when I would like to have an overview, to get a quick overview of how my network is behaving. In this video, I would like to talk a little bit about different types of network issues, show how you can set up MTR command to make it more aggressive, and then, well, to demonstrate MTR by simulating network errors using NetM. NetM is a is a kernel module which you can use to simulate network issues. Yeah, so MTR is used to track down real-time issues, like issues that are happening at the moment you are watching the command play out. So it's often issues that are manifesting themselves within a time frame of 1 to 60 seconds. And say like you have an issue with a real-time application, and you wonder why it's slow, like your SSH, and you're typing characters and it takes time to get an echo on your characters. Then you're like, and it's sporadic. It's not always just sporadic. Then you can use MTR to verify that your network is okay. So, and I also like to use this MTR in a normal situation just to get a feel for how my network is behaving, because I can see how the network is behaving in regards to packet loss and latency. So a good network, you shouldn't have any. There should be zero packet loss, and your latency should be quite low, like under 15 milliseconds, or it depends on what type of network you have. But if it's all cable, then everything should be under 15 milliseconds. It depends on your on how far or how big your network is, like physically, how far it stretches in the geographic sense. So I use this to identify bad links and bad routers. What type of network issues can you have? Well, as I mentioned, you have packet loss and high latency. And these issues can be caused by different types of problems. So you can have a shaper and a link capacity. If you fill up the link, then the shaper can generate packet loss. And if you have exceeded link capacity, then of course you will also get packet loss. Can be something wrong with your optics. So there could be an error in your SFP, like the physical hardware that actually transmits the data on the fiber optic cable. There can be something wrong with the fiber optic cable, router config software or hardware. High latency due to long distance, but it could be a radio link, a shaper, CPU issues, or hardware issues. So latency is actually quite nice to locate if it's hardware issue, because, and also latency, you can use this if the network equipment struggles to transmit a packet due to some issues, then the network equipment will use longer time to send this packet because it struggles to get to verify that the packet has been sent. And then you can, but this is transmitted to you, or like this information comes up to you as a high latency. So high latency could also be due to something on a lower level, is losing packets. For instance, in a wireless network, if you have retransmissions on the Wi-Fi link, you could see this as a high latency, but you don't actually get a packet loss, but you get a high latency issue on a Wi-Fi link. So yeah, high latency radio links, because you have poor coverage, shaper, CPU issues, or hardware issues. And when you use MTR over a long period of time, you build up a feel for the different types of issues when you get experience on using this program. Okay, so now I would like to try to simulate some of the issues and show you how I tune MTR to detect them, especially the sporadic issues. Okay, so yeah, MTR. This is how you get a GUI window. I don't like to use this GUI window. I like to use cursors. So now you see I'm just pinging my own host. Also, how to get this tool. I like to use a Debian-based system. So in a Debian, you just type apt install mtr. You also need to have sudo, and then you see it's already installed. And of course, yeah. But okay. But I would also like to make this MTR more aggressive to help me troubleshoot the network. So what I like to use is to increase the interval here to 0.1 seconds. So I send a ping packet, or I do a trace route each 100 milliseconds, or 10 times in a second. I also like to stress the network a bit by increasing the packet size. So let's see, packet size. Here, packet size. So I like to put this at 1470, because then you have 30 bytes for extra headers. And now you need to use sudo, because having this, what I call a rapid ping, you need to run MTR as a root. Yes. And also I like to have it in my command line window. So then it's also curses like this. Okay, so now we are running a trace route towards UiO, that's the Norwegian University of Oslo. And I like to use them now because the university network is quite nice, and because it's stable, they don't have policing on their routers, so each of their routers are responding to my pings, even if I stress them a bit. So that's quite nice. And the MTR, it takes commands from you now. So you can type commands now and then it will do stuff. So I like to just press the letter D for David. And when I do this, I scroll through to a different view. So this view here shows you the packet loss. And now we see it's all dots, meaning that all our packets are getting answered, except for the first hop here. And this is my puny home router, and it's defending itself because it gets a bit stressed. So then it drops many packets, except for some packets, because it runs policing. So when you see a question mark, it means a packet has been dropped. And to see difference in latency, because now we don't see any latency here. You press David or the letter D again, or delta, then you see how each hop is responding in latency. So you see hop number 3 is all the packets are responding, or almost all of the packets are responding within the one here. You see the scale here. 1 is 24 milliseconds. So all of the packets, except here's a tree that used 93 milliseconds. But overall, we can see that the network here is stable. It responds in a app time. But here you saw something like this bigger than sign. It means that the respond time was outside of this scale here. So it was much larger. It was much larger than 523 milliseconds. So we see that sometimes this hop number 3 is having some issues, but it is not affecting our production traffic because we don't have any packet loss towards a hop 10. And that's important to remember, that you can see packet loss on the hops here, but it doesn't matter because our end host is responding. But okay, so now I will introduce some delays by this netm. So then I need to run this as root, and now you see at once all of our was A. So we see up here A is 134 milliseconds. Change, and say we change this to 150, and then you see something is happening, and then we go down to 50, and you see that all the changes are propagating from hop number 2. So when we see this crazy latency, we know that there's something from hop 0 to 1 or from 1 to 2. So that's like crazy high. Okay, so you can use this to give, like, so now my focus is on hop 0 to 1 or 1 to 2. Okay, and we can also have a bit more sporadic latency, just to show that. So I'll just do 50 like here. I'm sorry. So then you see like the latency is more sporadic, and you see 2, 2, 3 up here, and you see it propagates. So at once your focus goes up to hop number 1. Okay. So now I will go to the packet loss view by pressing D for David, and then I will put in some packet loss. Let's see, where is the packet loss? Copy. Now we'll have a little bit more packet loss to make it more clear. So now you see I've introduced some packet loss, and you see there's less random question marks here because we have random packet loss of 1%. And you could, and this affects our target, so hop 10, so then it's like a series. Our traffic towards our target is affected. And we are wondering, okay, so where in this path is the is the root cause for this packet loss. And we see that, okay, up with hop 8 and 9, there's packet loss, but we can also see that we also have packet loss with 5 and 4. But we also get packet loss with hop 2 here. So then I would suspect, so now my focus is going upwards. So it's thinking like, okay, so it could be hop 0 to 1 or from 1 to 2, because I have packet loss in 2. If I only saw packet loss from hop 5 towards 10, then I would think that, okay, there's something wrong with maybe 4 to 5, and yeah. So this is how you can like more identify where on the path the problem is. And because when you do a ping, yeah, maybe I do 10 pings here. And like the ping is happy, it hasn't seen any packet loss. 0%. But clearly we have packet loss. We have 1% packet loss. And since we have tuned MTR to be more aggressive, then we see the packet loss quickly once. Okay. So we have the D, and we also have the J command, so to see the absolute drops. So then you see here more clearly, like you have same amount of drops here, only for auto 1, but that's like, yeah. So that was J as in Juliet, to go through the other view. And you can press N to see just IPs, N as in November, and you can do H to get a help, and yeah, but I don't use. I often use just J as in Juliet and D as in David. Okay, but typing this command is a long one, so it's nice to create in Linux. You can have alias or alias. So I have created an alias in file bash aliases, and I have just typed m like this. So then when I do m uio.no, yeah, it's probably because I packet lost it. Spent a bit of time there. And then I can turn off the packet loss. So I can just do del, and then it's fine. So then everything's fine. So then I will do a rerun like this. I'm like, if I fix something, I'm like, and I like to take it J and Juliet, and I see, yeah, that's good. Okay. So yeah, so that was a demonstration how to use MTR to troubleshoot network issues like a professional. Yeah. So I've been using this tool for the last 10 years, and it's like one of my main tools. And my colleagues, when I showed them this tool, they were like all like, "Ooh, so cool!" So yeah, so this is why I wanted to record a video. And this is my second video, so you have to excuse me if it's a bit slower. Yeah. But okay. Yep. So this was the video. Okay. Take care and bye bye.